This next lesson is on complex fractions. A complex fraction is a fraction that has another fraction in the numerator and or the denominator. So here are some examples. So we have a fraction in the numerator and then another fraction in the denominator. On the second one we have two fractions being added in the numerator and then one in the denominator. On the third one we have a whole number, but we still have a fraction either in the numerator or in the denominator. So all of these are examples of complex fractions. Now, the word complex in English usually means really hard or really complicated, but complex in math doesn't necessarily mean that these problems are going to be really hard or complicated. It just means that there's a fraction within another fraction. Now, another example would be if you had like the 21x to the fourth over 8y divided by just like 7, okay? That has a fraction in the numerator, then there's a big or longer or bolder fraction bar, and then only a whole number in the bottom. You can have a whole number in the bottom or a whole number in the top, just as long as there is at least one extra fraction either in the numerator or the denominator, then the whole thing's a complex fraction. So a complex fraction is considered reduced when there is only one fraction bar in the expression. There are two methods that work to reduce all complex fractions, but some problems are more conveniently reduced using a particular method. So we're going to split all complex fractions into two groups, either single fractions or multiple fractions. So let's explain what those are. Single fractions. We will call all complex fractions with, and this should really say at most, one fraction in both the numerator and at most one fraction in the denominator. We're going to call that a single fraction. So this has one fraction in the numerator and one fraction in the denominator. Notice there's no pluses or minuses having like a second fraction. This one has one fraction in the numerator. This one has no fractions in the numerator. Yes, there's a plus or minus, but there's no fractions there. So there's only at most one fraction in the numerator, one fraction in the denominator. So on multiple fractions, we will call all complex fractions with more than one fraction in the numerator, denominator, and multiple fractions. There will have to be an addition sign or a subtraction operation in the numerator or denominator. So this one right here has a fraction, but it also has another term here. Now I know one is a whole number, but you could make it into a fraction, so that's actually two fractions because there's an addition sign there. So here we have subtraction signs, so again that's more than one, more than one. So this one has more than 1 in the numerator because there's a plus. This one only has 1, but it's still a multiple fraction because there's more than one fraction in either the numerator or the denominator. So we're going to show you a method that is easiest to do on single fractions for method 1, and then we're going to show you a method that is easiest on multiple fractions. So for single fractions, for method 1, what we're going to do is simply change the division into a multiplication by multiplying by the reciprocal. We did this in an earlier lesson when we divided rational expressions. So I need you to understand that this divide sign right here, this red divide sign, can be rewritten with a divide sign like that. So we could have our first term 21x to the fourth over 8y, and then instead of the bar we could use the divide sign 7x cubed 16 over 16y squared. Now this is a divide sign. We actually already know how to do that. We're going to change that into a multiply sign by reciprocating the second fraction. So the second fraction becomes 16y squared over 17x cubed. The first fraction, 21x to the fourth over 8y, stays the same. And then we look for any common factors that can divide out. It looks like 21 and 7 both have a common factor of 7, so I can divide both the numerator and denominator by 7. Also, 8 and 16 can be divided by 8. This process gets a little messy, so halfway through sometimes you might consider multiplying the numerator. So 3 times 2 is 6. We still have x to the fourth y squared. 1y times 1x cubed is x cubed y. And even though there's more to be done, it sometimes makes it easier when it's not so messy. So the numbers are all reduced, and now I can reduce my x's. I have 4 in the numerator and 3 in the denominator, which leaves me with 1 in the numerator, 1 copy of x, or x to the 1. In the y's, we have 2 in the top and 1 in the bottom. When I divide out, I have 1 left. So that gets me 6xy. On the next fraction, notice we do have one long fraction in the numerator, one fraction in the denominator. Yes, there's adding and subtracting, but because the bar goes all the way across, that's one long fraction in the numerator, one long fraction in the denominator. So this is a single fraction. So I'd like to rewrite this long division bar into a horizontal division problem. So we have x squared minus 5x plus 6 over 10x plus 5 divided by 4 minus x squared over 6x plus 3. All I did is I changed that divide bar into more of a horizontal division problem. So we don't really like dividing fractions, so we are going to change the divide sign into a multiply sign by taking the reciprocal of the second fraction. So that gets me 6x plus 3 over 4 minus x squared. The first fraction stays the same. And now this is a simple problem that we've actually done in the past. We just factor and reduce. GCF on the bottom. Over in the blue, it looks like I have a GCF in the numerator. And that one's out of order, isn't it? So I'm going to rearrange that to be negative x squared plus 4. Then I want to factor out a negative 1 to get x squared minus 4. And now that's going to be a difference of squares. X minus 2, x plus 2. Everything else stayed the same. Now I can divide any numerators and denominators that are exactly the same factors. I see a 2x plus 1 that I can divide out. I also see an x minus 2 I can divide out. So it looks like my final answer is 3 times x minus 3 over negative 5, because a positive 5 times a negative 1 is negative 5, x plus 2. On our third problem, we have again another single fraction in the top and another single fraction. So I'm going to rewrite that long divide sign into more of a horizontal divide. Now I don't like dividing fractions, so I'm going to change that into a multiply by taking the reciprocal of the second fraction. And the first one stays the same. Now notice that the numerator is in the wrong order, so I'm going to rearrange that to be in the right order. So that saves me a step here when I go to the next step to factor. So I'm going to factor out a negative 2x. Don't forget a positive 2x divided by negative 2x is negative 1. Don't forget to write your 1 there. Then x plus 1, x minus 1 is a difference of squares in the denominator. Over in the blue, the denominator can't factor. The numerator factors. I'm going to try 2x and 1x, and then 3 and 1. With both of the same signs, I'm trying to get to 5x. Yep, positive, positive. So that gets me 2x plus 3 and x plus 1. I happen to guess and check and get it right on the first try. And then I divide out any common factors in the numerator or the denominator and the denominator. So if x plus 1 is a common factor, I also see x minus 1 as a common factor. The 2 and the 6 divide out as well, and that gets me 3 in the denominator. And one of the x's with one of the x's. So what do I have left in the numerator? I have 2x plus 3, but I also have the negative. Don't forget that there's a negative 1 out in front. And in the denominator, I have 3 and an x left. And that is my final answer.